Hi, this is Mr. Kingsbury, and today I would like to go through the Unit 2.01 notes for you. This unit is all about polynomials. We're going to add them, subtract them, multiply them, and divide them. And in fact, those first three things are all things that you should have done in Algebra 1, but since that was a couple years ago, we're going to take this first day to just review. So let's jump down to the basics. Before we can talk about polynomials, we need to understand what a term is. A term is either a variable, a number, or the product of a variable and a number. That is, they're being multiplied. Here are some other examples. And just to give you an extreme one, so anything like that. What you'll notice is there are no pluses or minuses, no divisions. It's all multiplication. Remember, if there isn't a sign, it's understood that it's multiplication. So why do we need to know what a term is? Well, terms are what make up polynomials. So we need to know what a term is so that we can understand what the different types of polynomials are. So to begin with, we have a single term. A single term is called a monomial. One term, mono meaning one. Here are some examples of those. Everything that I just showed you before, those were examples of monomials as well. 5x, 12x squared, 9x, negative x, etc. These are all monomials. If you put two of them together, you have what's called a binomial. Bi means two, like bicycle, two wheels. Biplane, two wings. Here are a couple examples. 3x plus 4, 2x minus 17, so forth. Notice now we're taking two terms and we're connecting them with either a minus sign or a plus sign. That's what causes the larger polynomials. If you take three of them, we call that a trinomial. Tri is three, like a tricycle, three wheels, right? Here's a great example. X squared plus 5x minus 4. We've actually been factoring things like that. This is another one. This is not a quadratic trinomial. This is a quadratic trinomial. This is not, but it's still a trinomial. It's got three terms. Anything that is larger than 3 we just call a polynomial, and polynomial is the general term we give to anything that has one or more terms. So anything can be a polynomial, but if it has 1, 2, or 3 terms in it, we have special names: monomial, binomial, trinomial. Another very important thing about polynomials that we need to understand is the degree of a polynomial. And it's actually pretty straightforward. The degree of a polynomial is simply the largest exponent. And it doesn't matter how many terms there are. You look at all the terms, and whatever the biggest exponent is, that's your degree. Okay? So let's take a look at a couple of examples here and see if we can identify what kind of polynomial they are and what the degree is. So number 1 here, I have 1, 2 terms. That makes it a binomial. And if I'm looking here, I just see the one exponent, that's a 5. So we will say that the degree is 5. Number 2, we have 1, 2, 3 terms. That makes it a trinomial. And I'm looking, and again, I just see the one exponent. It's a 2, so the degree will be 2. You could also say it's a second degree polynomial. You could say this is a 5th degree polynomial. For the sake of time, I'm just writing degree whatever. Then number 3. We have 1, 2, 3, 4, 5 terms. Well, that's more than a monomial, a binomial, or a trinomial, right? That's more than 3. That's 4 more. So we'll just call this a polynomial. Poly means many, by the way. Polynomial. So 1, 2, 3, 4, 5, polynomial. Also, you'll notice that there are multiple exponents, 3, 2, and 4. No big deal. We just go with the biggest one, which is 4. So this is a degree 4. Easy peasy, lemon squeezy. Now the rest of this is all about doing stuff with polynomials. And today we're going to look at adding them, subtracting them, and multiplying them. So to do that, we need to understand the concept of a like term. Like terms have the same exponent, the same variable raised to the same exponent. And it must be both. It's wonderful if two terms both have an x in them, but if one of them is raised to a different exponent, they are not like terms. So for example here, we've got 7x squared and 3x squared. Now I don't care that the coefficients are different. These are both x squareds, so they are like terms. Let me give you a non-example. 3x squared and 2x cubed. Again, I don't care that the coefficients are different. They both have an x, but this is raised to the second power, this is raised to the third, so they are not like terms. So let's practice that. I have here some like terms, or some terms, and let's figure out which ones are like terms or not. So let's start with 17x. What I want to do is find anything that has just an x in it, and that will be a like term with 17x. So let's see. That's an x cubed y. Yeah, it has an x, but it also has a y, and this x is raised to the third power, and we want just an x. That's just a g. Here we got 5 halves x, so that'll be a like term. Just a y, just g, just a y, xy. So it has an x, but it also has a y, and ours, they don't have it, a y. They just have an x. So x cubed y, w, xy, w. Unfortunately, it's just those two. There weren't any others. Let's try the next one. We got 4x cubed y. So anything that will be a like term to this will have an x cubed y in it. Let's see. We got just a g, just a y, just another g. 9y. There's an xy. Here's an x cubed y, so that'll be a like term. We get a w, an xy. Okay, so these have x and y, but notice the x's are not raised to the third power. So they're really close, but they're not like terms. And then we got a w. So it's just the two. Next up, we've got negative 12g. So we're going to look for anything that's just a g. We got just y. Here's just a g. That's a like term. Just y, xy. Just w, xy, and another just w. So it's just those two that are like terms. What do we got next? Negative 4/3 y. Cool. So anything with just a y is what I'm looking for. Well, there you go, right off the bat. 9y is just a y. We got negative 8xy, so it does have a y, but it also has an x, which we don't want. 1/3 w, nope. 4xy, and 4,587 w. Again, not y's, so not like terms with what we're looking for. Let's do these xy's then. Negative 8xy. So anything with an xy in it will be a like term, like this 4xy. But you'll notice these last ones, 1/3 w and 4587 w, they have w's, not xy's. Turns out they are like terms as well. So that's how you do that. Now let's talk about adding, subtracting, and multiplying. In order to do these things, you have to pay attention to the signs of stuff. Now, multiplying is pretty awesome. You don't have to worry about any signs. You don't have to worry about changing anything. Addition is the same way. You don't have to worry about changing any signs. Everything that has been given to you already has its sign where it needs to be, and everything is good. It's subtraction where we have to make sure we do a little bit of sign changing. And we'll talk about that in a second. So let's start with addition. Adding stuff is just combining like terms. In fact, the problems that you'll be given, they will have parentheses in them, so you can see where the different polynomials are, but you don't have to really keep those because everything's already the right sign, so you can just drop the parentheses and combine the like terms. With subtraction, it's almost an addition problem. It wants to be an addition problem, but because you have stuff that comes after a minus sign, all of that stuff is actually not the right sign. So you're subtracting it all. So you have to make sure that you adjust to show that when you drop the parentheses. Really, that's what it's all about in all this, is when can I drop the parentheses. So typically with subtraction, the polynomial before the minus sign, you can just rewrite it without a set of parentheses. But the one after the minus sign, probably what you're going to want to do is change all of the signs inside of those parentheses and then change the minus to a plus. And I'll demonstrate that for you. And then lastly, with multiplication, you have to make sure that you multiply every term in the first polynomial by every term in the second polynomial. And people have a problem with this. So I'm going to actually show you 3 different ways to multiply polynomials on 3 different examples, because that's how I roll. So let's take a look here at a few examples. Let's start with number 1. So here's number 1. It says 9x squared minus 4x plus 17, that's one polynomial, plus 2x plus 35. As I mentioned before, with addition, you don't have to worry about the signs too much. With addition, you can drop the parentheses immediately. So I'm simply going to rewrite this. And then I'm going to find like terms. And we always start with the term with the largest exponent. In this case, that's going to be 9x squared. And I don't see any x squared, so I'm just going to copy it. I didn't see any other x squareds besides that one. Then I see x's. So I got negative 4x and positive 2x. When I combine those, I'm going to get negative 2x. And some students are like, how'd you get that, Kingsbury? I like to think of it in terms of dollars. A negative number is money that I owed or borrowed, and a positive number is money that's in my pocket. So right now I owe $4. I have $2 in my pocket, so I'm going to pay that back. Now, I don't have the amount of money, the amount of money in my pocket is less than what I owe, right? So when I pay back my debt, I'm paying part of it, but I still have money left over, right? So that's really the question here, is how much money do I have left over? Well, if I owe someone $4 and I pay them $2, I still owe them $2. And then lastly, we have our constants, positive 17 and positive 35, which if we put those together, we get, I believe, positive 52. And that is the result of adding those two things. Pretty straightforward. Next up, we have a multiplication problem, number 2. And the first method I'm going to show you is the box method, which we have already used to do factoring. So we got w plus 3 times w minus 4. Now, the biggest mistake people make is they'll multiply the first term and each by each other, w times w, and they'll multiply the last one. And that's all they do. Now, it's not that that's wrong. That's part of it, but there's more. You also need to multiply these two and these two. A good rule of thumb when you're multiplying is to count how many terms are in the first polynomial, in this case 2, and how many are in the second, also 2, and multiply that. If when you're done multiplying, before you collect like terms, we don't have 4 terms, that's a problem. Now I'm going to do this with the box method. I got 2 terms in my first polynomial, 2 in my second, so I'm going to do a 2 by 2 box. And I'm going to put w and positive 3 there, and w and negative 4 there. And I'm just going to treat it like a multiplication chart. W times w is w squared. W times negative 4 is negative 4w. And 3 times w is 3w. And 3 times negative 4 is negative 12. And look, I certainly have 4 terms, which I will now write out. W squared minus 4w plus 3w minus 12. And once again, I need to combine like terms. So I'm going to start with w squared. I don't see any other squares, so I'm just going to rewrite w squared. Then I have my 2 terms that have a w, negative 4w and positive 3w. When I put those together, I got 4 negatives and 3 positives. So I owe someone $4, I pay them 3, I still owe them 1. And then lastly, we have our constant. Oh no, that is a negative 2. We've got minus 12. Sorry, I misread what I wrote because I didn't write clear enough. And that should be minus 12. And that's multiplication. That's pretty straightforward. Gotta love that. Now let's do a subtraction one. So this is the one that takes a little extra work, but not tons. So number 3, I realize that's a lambda, but I'm going to use x. So we got 9x squared should be minus 4x plus 17 and then we will subtract 2x plus 35. And that may look familiar because those are the exact polynomials from number 2. Now, as I mentioned, the whole point when we're adding and subtracting is to figure out when we can drop the parentheses and just combine like terms. With addition, we can do that immediately. With subtraction, not so much. So for starters, this first polynomial, 9x squared minus 4x plus 17, I'm not going to do anything with that yet. Its signs are good. The problem signs come after the minus. So I'm going to change the minus to a plus, and then I'm going to take everything in these parentheses after the minus and change their signs. Positive 2x becomes negative 2x. Plus 35 becomes minus 35. Now I've turned it into an addition problem. So now I can just drop the parentheses. 9x squared minus 4x plus 17. And you can put plus negative 2x if you want. I'm just going to put minus 2x and then minus 35. And then once again, I need to collect the like terms or combine the like terms. So I have a 9x squared. I don't see anything else with an x squared, so I will just rewrite that. Then I have negative 4x and negative 2x. So this is like I owe someone $4 and I borrow 2 more, so now I owe them $6. And then lastly, we have our constants. This is positive 17 and negative 35. So it's like I owe someone it's like I owe them $35 and I have 17. Well, that's not enough to cover the debt. So after I pay them back 17, I still owe them 18. So I get 9x squared minus 6x minus 18. I'm going to skip. Do I want to do that? I probably do. I'm sorry. I'm going to skip number 5 and 6, I was just thinking. But I should probably do number 4 first. So how about we take a look at number 4? Number 4 is 2b minus 7 times b squared plus 2b plus 3. It's actually a beta, but I'm just going to call it b. And that's actually a minus 3, not a plus 3. My bad. So this method, the next method I'm going to teach you for multiplying polynomials is called the distributing method. We're going to take each term in the first polynomial and we're going to distribute it over the second polynomial. And I'm actually going to write that out. So the first term is 2b. And then behind that I will put this whole other polynomial. B squared plus 2b minus 3. Then I'm going to take the second term in the first polynomial here, negative 7. That's minus 7. And I will multiply the entire second polynomial by it. So b squared plus 2b minus 3. And then all you do is distribute and collect like terms. So 2b times b squared is 2b cubed. 2b times 2b is 4b. And 2b times negative 3 is negative 6b. Then we'll distribute this negative 7. Don't forget the negative. Very important. Negative 7 times b squared is negative 7b squared. Negative 7 times 2b is negative 14b. And negative 7 times negative 3 is positive 21. And now we collect the like terms. So I see 2b cubed. I don't see any more cubes, unfortunately, so we'll just copy that, 2b cubed. Let's see, I see a 7b squared. So we'll go minus 7b squared. And I think that I may have made a mistake. This should have been a 4b squared. My bad. Which means this is also a, this is also a negative, this is also a b squared. Wow, I'm just making a mess of all of this. So actually I should have combined positive 4b squared and negative 7b squared. It should be negative 3b squared. My apologies for that. Then I have negative 6b and negative 14b. That's like owing someone $6 and borrowing 14 more. Now you owe them $20. And then lastly, we have our constant, 21. Just copy that down, and we're good. Outstanding. Let's see. I mentioned I wanted to skip 5 and 6. And I think that I would like to do number 7. So number 7, we have 10m cubed minus 4m squared plus 17m minus 12 minus m squared minus 13 minus 9m cubed minus m to the 5th. And it is a subtraction problem. So remember, with subtraction, we're going to leave the first polynomial alone. So I will copy it. We're going to change subtraction to addition. And then we will change the signs of all these things in the second set of parentheses. So m squared becomes negative m squared. Minus 13 becomes plus 13. Minus 9m cubed becomes plus 9m cubed. And minus m to the 5th becomes plus m to the 5th. And now that we've done that, it has become an addition problem. So we can just write everything without a parenthesis. 10m cubed minus 4m squared plus 17m minus 12. And you can do plus negative m squared if you want. I'm just going to put minus m squared plus 13 plus 9m cubed plus m to the 5th. And now we collect like terms. So let's start with the biggest exponent. And I'm sorry, mine doesn't look much like an exponent. I didn't write it well. But m to the 5th is going to be our biggest exponent. So we'll start by copying m to the 5th. Then we're going to look for the fourths. Do I have any fourths? I don't have any fourths. Then we'll do the thirds. I got 10m cubed and 9m cubed. When I put those together, I get 19m cubed. Then we have our squares. So we've got negative 4m squared and negative 1m squared. Remember, if we don't write out a coefficient, it's implied that it's 1. Very important. So we put those together. Negative 4 and negative 1 is negative 5m squared. Looks like we just have one term that has an m. That would be 17m. So we will add 17m. And then lastly, we have our constants. Negative 12 and positive 13. When I put those together, that's like owing someone $12. You have 13 in your pocket. So once you pay them back, you still have $1. Go you. And then the last one I want to do is number 8. We're going to skip 7 and 9. I want to do number 8 for you just to show you the long multiplication method. So here we go. So number 9 is actually a pretty simple problem. We've got x squared. I'm using x instead of lambda, which is that weird Greek letter there, times 9x minus 4. Now, the nice thing about multiplication is it's commutative. That means I can do it in any order I want. And that's going to allow me to do what I'm about to do. So I'm going to take the longer of my two polynomials, 9x minus 4, and then I'm going to put the smaller one underneath it, x squared, and I'm just going to multiply like you would two numbers when you first learned how to multiply long style. So negative 4 times x squared is negative 4x squared, and 9x times x squared is 9x cubed. And you're done. Thanks for playing along. I will see you in class.